Welcome to The Explainer. Look, if you've ever felt completely overwhelmed by a new process at work, or maybe you found yourself clinging to a bad habit even when you desperately want to break it, you are absolutely not alone. I mean, we've all stared at a simple software update on our phones and felt this completely irrational wave of dread wash over us, right? Well, today, we're diving into the fascinating biology of exactly why we resist change. And honestly, here's the best part. We are going to completely shift the blame away from your perceived lack of willpower and put it exactly where it belongs, on your very own nervous system.
So, you really have to wonder, why do we so often choose a certain hell over an uncertain heaven? When you say it out loud, it sounds completely irrational. Why stay in a routine that makes us miserable instead of taking a leap towards something that could be amazing? But actually, from a biological standpoint, it makes perfect sense. Our brains are, at their core, prediction machines. They're constantly trying to guess what happens next just to keep us alive. Because of that, they crave the safety of the familiar, even if that familiar situation is painful or super stressful. To your brain, familiar pain is safe simply because it's predictable. The unknown strips away our control, and our biology treats that unpredictability as a massive existential threat.
All right, to give your brain that predictability it craves, here is our roadmap for today. First, why change feels dangerous. Second, the power of habits. Third, navigating social threats. Fourth, fixed versus growth mindset. And finally, rewiring your brain.
Let's kick things off with Section 1, Why Change Feels Dangerous, the Anatomy of Resistance.
Meet your amygdala. It's this tiny, almond-shaped structure sitting deep inside your brain, and it basically acts as your automatic threat detector. It runs totally on autopilot, completely beneath your conscious awareness. Now, when life is predictable, the amygdala is calm. But the second you introduce change, it reacts to that unpredictability by slamming the panic button. And here's the catch. Human evolution hasn't exactly caught up to the modern corporate world. We haven't really evolved past our days on the savannah. So when a sudden restructuring or a new office policy drops, your amygdala doesn't see a logistical hurdle. No, it literally sees a hungry lion in the tall grass. It treats a new process at work exactly like a physical predator, triggering your fight, flight, freeze, or appease response.
And get this, the cost of that panic is incredibly steep. When your amygdala detects a threat, it triggers what's called an amygdala hijack. This biological reaction can actually wipe out up to 40% of your cognitive capacity. It quite literally shuts down the logical, rational parts of your brain to reroute all that energy to your body, getting you ready to run or fight. Just picture being in a meeting where a massive organizational change is announced out of nowhere. If you've ever felt your mind go completely blank, or you suddenly couldn't articulate a basic thought, that is a 40% drop happening in real time. It makes it nearly impossible to think strategically or embrace new ideas when you're caught in the middle of a sudden transition.
Moving right along to Section 2, the power of habits, wired for repetition.
So why is it so incredibly hard to break old patterns, even when we consciously know it's good for us? The answer is the basal ganglia. This is a region near the center of your brain that acts as this powerful efficiency engine. Its entire job is to form habits and automate behaviors, so you don't even have to think about them. Think of it like your smartphone automatically switching to low power mode to save battery. The basal ganglia loves routine because conscious thought burns a ton of calories, and routine saves precious brain energy. When change interrupts those deeply entrenched neural pathways, it forces your brain out of low power mode. It has to burn extra energy, and that actually causes a sensation of deep physical discomfort.
The really crucial piece here is understanding the habit loop. Your brain links a specific cue to a routine, and then it reinforces it with a huge hit of dopamine, the feel-good chemical. Over time, that dopamine release hardwires the behavior right into the basal ganglia. So when you try to break a habit or adopt a new process, your brain is suddenly cut off from that expected dopamine hit. You're literally going through a mild form of chemical withdrawal. Your nervous system is starving for its usual reward, which is exactly why your body fights so incredibly hard to pull you back to your old, comfortable ways.
Now, here is a number you absolutely need to remember: 40 to 50. It takes an average of 40 to 50 repetitions just to build a new habit and physically thicken those new neural pathways in your brain. This is huge because it relieves us of so much guilt. Look, when you fail to adopt a new workflow on the third or fourth try, it's not a moral failing. It's not a bad attitude or a lack of motivation. It's just a matter of biological repetition. You literally have to put in the reps, 40 to 50 of them, to build the neurological infrastructure needed for a new behavior to actually stick.
Which brings us to Section 3, navigating social threats, the SCARF model.
Change doesn't just happen in a vacuum, right? It happens at work, within our families, and in our relationships. Because of this, change deeply threatens our psychological safety. And neuroscience reveals something truly staggering here. The human brain processes social pain using the exact same neural circuitry as physical pain. Let that sink in for a second. Your brain literally cannot tell the difference between burning your hand on a hot stove and being alienated in a team meeting. When change is poorly managed and we feel rejected or socially displaced, our brain reacts with intense physical alarm. In fact, exposure to social rejection can cause an immediate 30% drop in reasoning ability. This is where Dr. David Rock's SCARF model comes in. It perfectly maps exactly what our brains are so desperately trying to protect in social situations. Let's break it down. Status is our need to feel competent. Nobody likes suddenly feeling like a beginner again on new software. Certainty is our need for predictability. Autonomy is our need for choices. We all hate feeling micromanaged. Relatedness is that deep human need for connection and feeling like part of the group. And finally, fairness is the need for equitable exchanges, ensuring we aren't getting a raw deal. Threatening any of these 5 elements during a transition will instantly trigger that massive amygdala resistance we talked about.
All right, Section 4. Fixed versus growth mindset. Shifting perspectives.
So knowing the biology is heavily stacked against us, how do we actually overcome this neurological roadblock? Well, I absolutely love this quote from psychiatrist Viktor Frankl. When we are no longer able to change a situation, we are challenged to change ourselves. This carries incredible weight when you consider Frankl was a Holocaust survivor. He endured unimaginable circumstances totally outside his control. Yet he realized that while we can't control the constant shifts of the world around us, we absolutely retain the power to control our internal response. And that response? It's dictated entirely by our mindset. The difference really boils down to this. A fixed mindset views any struggle or setback as a final verdict on your identity. If a new process is hard to learn, your brain says, "See, you just aren't good enough to do this." A growth mindset, on the other hand, views that exact same difficulty simply as valuable data. It separates who you are from how you perform. Discomfort is literally just the sensation of your brain learning something new. Neuroscience shows that adults who cultivate this growth mindset are way more resilient because they stop interpreting the friction of change as an existential threat to their self-worth.
Finally, Section 5. Rewiring your brain. Neuroplasticity in action.
Okay, so how do we physically change the wiring of our brains? Your secret weapon is right behind your forehead, the prefrontal cortex. This is your center for rational decision-making and emotional regulation. But here's the critical trick. The prefrontal cortex operates just a tiny bit slower than your panic-driven amygdala. It takes about 300 milliseconds for chemical messages to travel up and reach it. So by simply taking a slow, deep breath and forcing a deliberate pause, you give this highly logical part of your brain the crucial fraction of a second it needs to step in, assess the situation calmly, and completely override the amygdala's primitive panic. Clinical director Dr. Sophia Brandstetter actually outlines 6 practical steps to help us leverage neuroplasticity. And neuroplasticity is just the biological fact that your brain can form new connections at any point in adulthood through focused repetition. It starts by simply noticing your self-talk, catching yourself when you say, "I always mess this up." Then, reframe that effort as data, not proof of failure. Use feedback as neutral info and, crucially, allow your progress to be completely non-linear. You have to forgive yourself for the setbacks because taking 2 steps forward and 1 step back is exactly how the brain physically rebuilds itself.
To put this into action tomorrow, try shifting through these 3 gears of uncertainty when you start feeling overwhelmed. First, the cognitive gear. Objectively review what's a plus, what's a minus, and what you'll try next. It keeps you focused on moving forward. Second, the emotional gear. Simply label your emotions out loud. Say, "I am feeling so frustrated by this software right now." Studies actually show that just naming a feeling instantly dampens the amygdala's threat response. And third, the relational gear. Share your experiences, connect with peers, and learn in public to satisfy that deep need for social safety we saw earlier in the SCARF model.
And that brings us to the ultimate takeaway of our entire explainer. Instead of seeking an illusion of certainty, adopt an experimental mindset. Think about the psychological relief in that idea. An experiment literally cannot fail. It only produces data. If you try a new routine and it's a total disaster, you haven't failed. You've just gathered excellent data on what doesn't work. Treating change as an experiment engages your prefrontal cortex in curious exploration rather than threat assessment. And over time, that mental shift creates new neural pathways that make uncertainty feel entirely manageable. So as you face your next transition, whether it's a massive new workflow at your job, a shift in your family routine, or a major life change. Just remember, you are not at the mercy of your biology. You possess a prefrontal cortex fully capable of overriding panic, and a brain that is incredibly adaptable if you just give it the right repetitions. So I'll leave you with this final question to spark your curiosity. What will you discover when you stop fighting the biology of change and instead approach your next big unknown as a grand experiment?